Hi. Now after we have everything ready on the data side and we have seen our plots, the graphs from the data and everything is corrected, our feature is selected. So now next thing is what left is train your models, right? Train your model, split your data so you can train it and also test it, right? So till now what we have done, just a small recap if you want to see here, we have able to load the data, okay? And I'm just going here in the flow, our flow, right? We were able to understand the data. We collected every data, we understood the problem statement, we did our exploratory data analysis, right? We use pandas, numpy, we now and later what we did we plotted it and after the plotting it we were able to understand and how data is dependent to each other. Then we were able to also remove some outliers, right? We were able to combine few features together like SIP-SP and Paj we combined, right? We were able to take out name, made it a feature, different feature called title, right? So now we did that. Now coming to the model part of it, right? So very important library is what we are going to use is the SkLearn. It's scikit-learn or sklearn you can call it. So if you have not installed, just go through and just install pip install the sklearn, okay? And then you can from sklearn.model selection. So this is where you have all the models, guys. sklearn.model selection here, right? In sklearn we have lot of different models which is already there. When I say models, right, it's like we want to use regression or we want to use KNN grouping, right? Or you want to use forest regression, logistic regression, whatever you are going to use, right? So it is there under sklearn. sklearn library has all this different kind of models. Okay, so from sklearn.model selection, I'm importing trend test split. Okay, because now first thing I want to do without training any model is I want to split my data so I can train it with the some data and I have some data left out to test it. Why you should not train for all the data, right? It will be your model will be overfit you, because if you have 100 samples and you're training your model with all the 100 samples, guys, then when you're testing the result will be very high. We don't want to do that, right? We want to split the data. So I just train it with 70 records or 80 records, and 30 or 20 records I'll just keep it aside so I can test it after my model training is completed. Okay, so same thing I'm doing here. Okay, importing trend test split and now dividing into x trend, x test, y trend, y test. Okay, and what is my test size? I'm giving 0.20. So 0.20 is my test data will be 20% and remaining 80% will be my train data. Okay, random state equal to 0. Now this, after I run this one, this will divide my data and create x trend, x test, y trend, y test for me. Okay, now if you remember that we had here train.csv and test.csv, right? But rather making my this test CSV or clear up and all, because there will be some impurity in that data also, right? There will be some impurity in that data also, which I don't want to clear now. I want to test my data with the existing data that I have in train only. So I will just test it first there, right? That is easy for me to do it. That's why I'm doing it. Okay. So now I have all this ready. Okay, I have train test, sorry, extend x test, right? Now next thing is like bringing that model from sklearn dot linear model import logistic regression. So why I'm doing logistic regression, not a linear regression here, guys? Because if you remember, linear regression is something if you don't have a multiple column versus one column. It's like comparing or taking out prediction from multiple columns. Input is multiple and output is one. Then something like logistic regression is very suitable. Linear regression cannot be used. Linear regression is very common if you have one versus one, right? Then in that case you can directly go with linear regression, right? Definitely there are other lot of things which will be dependent, but now in this case, so here logistic regression I'm using storing this into LR. So logistic regression, random state equal 30. I'm just giving it 30. I can go with 40 also. Okay, just giving random state that it will try for 30. Random state equal to 30. Okay. LR dot fit. So so I've stored my this logistic regression under LR, right? So LR dot fit. Now I'm fitting the train and X-train and Y-train, right? From here. So I divide this data into X-train and Y-train, right? So here I'm training it, correct? Here I'm training it, and next thing is like from where I have to predict is like my test set, right? X test and Y set. You don't get confused here. I'm training it here, so I'm fitting in the model. I'm fitting data into the model, which is LR dot fit, right? LR is my logistic regression where random is stated 30. This is very straightforward. I've given, right? I have not imported any other params here. I'm just going with the random state 30 and fitting my data here. Okay, let me run this one, and also I'll print the score here, or let me just run it first. Let me run it. Okay, running it. So now it says logistic regression random underscore 30 is completed. Okay, I already got this. Now let me add another cell. Print this LR dot score. So LR dot fit is a method, LR dot score is a method, and your test, again you will see I'm putting here test data. Okay, in test data I'm getting, okay, I'm getting 75.5% is my accuracy here, right? 0.75, so 75% is my accuracy, guys. See, I have not done any normalization. I have not done I tried with one random state. Let me go with a 40 here, right? I'll go with 40. You can change. So this hyperparameters, guys, you can always change it. This is how we actually get, best score from the model, right? Let me just go with a 40 here. If I run, let me test the, okay. So in random state 40 also, I'm not getting much difference. It's still 75%. Okay. Okay, so this was one model that I trained here, right? And the training was done, and I was able to get some score out of it. This is very straightforward, and why we used is because it was a multiple versus one derivation, right? Our X train, sorry, X versus Y. X was having a lot of columns, and Y has only one column, right? Generally, so that is why logistic regression. Now, next thing I want to try is I want to try KNN. So KNN is like K nearest neighbors, right? So K nearest neighbors means it just make it group items. So in the inside this model, I'm just trying to explain you in short way. It is like go with the nearest model, because now what it does, let's say if you plot into age, right? If you see the plotting here, if you remember, let me show you, bring plotting. Okay, so if you see uh, this particular graph into age, the right one, right? Here, if you see, if my, or take anyone, okay, let's take this one. This is very, so if I'm taking this particular point here, age 40, this particular point, right? If I make a circle, let's say if I make a circle here and provide my circle radius of 1 centimeter, let's say, just for understanding, I'm giving, let's say I'm giving this 1 centimeter, creating 1 centimeter circle. If you see here, if I create 1 centimeter circle here, actually chances of getting right result is also good here, right? Let's say if I make a circle here, the chances of getting, so I'm saying if this particular one is survived, the circle between 1 centimeter will be also survived. So in high level, this is what K means never do. Okay, so KNN is a model which does something very similar like this. We'll see in details when we have a video for all the different models, and we'll see it in detail. Okay, so now from sklearn dot neighbors import K neighbors classifier. Okay, so here we are taking classifier. Now when I'm running this one, same thing, right? Knn dot fit. So this model dot fit, this model is k neighbors classifier. Here we don't give, no, I have not given any parameter. Okay, and extend, it is already trained. Let me print the score. So printing the score, now I'm getting 72.72 or 0.72. 72 is my score. 72%, close to 73% is my score, guys. Right? So so if you see, without making any hyperparameter changes, also without normalizing or by directly importing these two models, I am able to good, I mean, not very good accuracy, but I'm able to good accuracy, which is good for the first time, right? And why we are able to get it? Because we did lot of things for preparing the data. So the preparing the data part is very critical, guys. That's why we took lot of time there. And without making any changes also, without making any changes, see, I'm able to get very good result. Not very good, but okay, like okay result for the very good result for the first time, right? Very good result for the first time, let's say, right? I have other models which I'm trying. I will try to make other models. I'm already going in the decision tree classifier also. Let me just show you. So now decision tree classifier is like it has multiple trees, and every tree you pass information and get out output, right? So let's say if you have a one model, you're getting out output. Let's say output is 1 and 0, whether survived or not survived, right? I have a same tree for I have a similar kind of model running in 10 different trees, and out of 10 different trees I'm again making 5 trees, and from that again I'm making some 2 trees, right? It's like output of one tree, or the first layer of the trees give output to the next tree, right? And this is how actually you make, or you take out lot of output, and finally you take out one output of it out of it. So that is a high level the tree classifier concept. Okay. So here if you see, there are a lot of parameters which I'm passing here, right? And this is I'm just taking for now randomly, guys. So I'm taking range to 32 and 1. So and range is 1, the sample sleeve is 1 and sample split is 2 10 1, and the splitters are best and random. Okay. And while running this one, let me run this one. So this is fitting 5 folds for each 8640 candidates. Now it make all this multiple levels, right? As I said, multiple trees level will be there. So it's totaling of 43,200 fits. So this training the decision tree classifier might take lot of time, right? It will take a lot of time here. So depend on your machine. So if you have a very high RAM and a very good configuration of your PC, then it might take less. So I have like a pretty good machine here, so it should not take a lot of time, but generally it takes, guys, like 30 seconds to a minute or 2 minutes. It can take depending on the data that you have, right? So it is training right now, and we have something called, so next step is something called grid search DT, best param. So this best param is a very good method, guys. If you just tell the model is getting any point, right? Best param. Okay, so best param is, okay, let me just, okay, it is still running. Okay, let me just write best param. Okay, and okay, see in SkLearn model selection grid search CV. So here I can see, so this best model is something that gives me what all parameter I should give. What is the ideal parameter that I should give for training my data? So that is very good, right? Rather trying randomly. So right now I'm given range 2. I have to change it to see all different kind of ranges, or all different kind of hyperparameter tuning I need to do to get best result out of it. And every time when I'm training, see how much time it's taking. That's why I'm running it right now. And it might come up in a minute, but if you have a data size which is very huge, right now the data that we have taken, that has only less than 1000 rows, right? Less than 1000 rows, and it was having only 5 or 6 uh, columns, right? And then also it is taking a lot of time to train this model, right? You just think, if you have to try this lot many times by considering all different parameters or different tuning that you're doing every time, how much time it will take. So this is where this best param comes into the picture, right? This best param is something that it search for the grid search DT, it takes this dt, and then finally it will if you run this one, this will give you the best parameters here, like best criterion, best depth, max depth that you have to give, right? All criteria that might bring the best output, or that might bring the best result from your model, it will bring it. Okay, so it ran finally, and I'm able to see this, right? It says 71 completed, and I will be able to see. That means my grid search dt.fit, right? This is completed. Okay, now this best param that we're thinking, we'll just run this to get our best parameters for the model. Okay, so now it's saying me use Gini max depth is equal to 7, sample leave 3, split 3 at random. Okay, it is giving me that I should use this. So let me put this Gini 7, samples leave 3 and split 3 and at random. Okay, so I will just run this again. Okay, I'm just using the same if you see, right, I'm just changing the param grid here in DTC. DTC is my I'm taking from here, guys. If you remember, DTC is my decision tree classifier, right? And the parameters is what I'm providing now, and the parameter which I got from the best params, right? So I ran this, I got this, and I'm running now, and it is done. Okay, so now what I will do, I will take the accuracy score for my DTC model. Okay, let me run this. Okay, so it is giving me 70, close to 79%, 78.97 is my percentage, is what I'm getting. Okay, so till now what I am seeing from all three models that I have, the decision tree is giving me the best result, right? With basic, like very basic tuning, we are just using best param, and we are getting whatever param which we are getting, we are using that. Okay, so let me because here depth we can increase, right? So our max depth is 7. Let's say if I make it 9, let's see what happens, right? We can try this hyperparameter tuning, and this might give you better result. So now it's giving me even much better result, right? It is giving me 80.6. 80.6 is what it's giving me, because I've increased the depth, guys. Because this is a tree classifier, right? So it will keep on increasing the depth if I increase the max depth here. So it is like this is a number of time it will get iterate and take the max depth. Okay, so I'll go ahead with this model because this is giving me the highest accuracy. Okay, so this is how we can create model, also predict our score, right? So that's all for this class. If you have learned something from the class, please hit the like button, subscribe to the channel, and hit on the bell notification. So next time when I upload a video, you'll get notified. Thanks for watching.